to have at least a week to look at it. We will answer questions on it next week if we need to. There was an announcement posted on Blackboard that had a misprint in it the first time I did it. I had the total as 364 points instead of 264 points. At this point, 211 points is your target. If you're at or above 211 total points for the course, you are at a C or better. So you're good. Now, if you're a little bit below that, don't worry. Remember this current test that you're just getting back. You can do corrections on that. That adds to that total. That still counts within that 211. So if you're close to it, your corrections should put you above 211. If you're a long ways away from it, talk to me. We may have to do something to get you going. So anyway, tonight we start Unit 3. Unit 3 is about investment and interest. There are two types of interest we are going to talk about. The first type is simple interest. Simple interest is just that. It is the simplest way that interest can be calculated. In simple interest, interest is only calculated when a significant event occurs. We'll discuss what those significant events are over the next couple of classes. Mainly is if there's a payment, a withdrawal, or the end of the term comes along. Then there's compound interest. Compound interest, a little bit more complex. In compound interest, interest is calculated at regular periods. Those periods may vary depending on the type of loan. Could be monthly, could be quarterly is very common, could be annually, semi-annually. Daily is an option. Continuously is something that was used a lot more 10 years ago. It's kind of faded now. It was kind of a fad for a while. The calculation is a little weird. They found that even computer systems, unless they were set up just right, didn't do the calculation real well. So I'm not going to make you do continuous compounded interest in here. I don't want to make you guys suffer quite that much. So let's go back to our simple interest. Like we said, simple interest is only calculated when there is a significant event. Now, for many of us, there are several loans we have that are simple interest without even realizing it. Car loan, in many cases, is simple interest. Actually, not in many cases. A car loan is simple interest, period. Now you might think about that, well, but they charge me interest every month. Yeah, but what do they expect to happen every month? Yeah, you make a monthly payment. So you can actually control on a car loan when your interest is charged by when you make your monthly payment. I know several people that will get like their tax refund and they'll make their next 3 or 4 car payments right now. And so it pays down the principal significantly because there's no interest. If you make 3 payments in the same day, there's no interest in between payments. So the whole payment goes towards the principal. Now it's going to sit there for 3 or 4 months and build up interest, but we'll look at the math behind that later on tonight. It still works in your advantage. Now, because of that, there are a lot of banks that have rules that you can't make more than 2 payments ahead. And if you're more than 2 months ahead of payments, it automatically goes to principal. Some banks actually, I know a couple of banks in the area have a rule that you cannot make a payment more than 30 days before it's due. Yep. 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 It'll show up that way. It shows that way on your payment stubs, but usually they still give you the advanced into the principal by making those early payments. Generally, the ones that have the pre-printed stubs, they're usually set up as automatic withdrawals from a checking account. It is. So so if you make, yep. Now, did they let you skip the payment the next month then? Okay. Because in a lot of places, when they set them up that way, where you've got the automatic withdrawals, if you make an extra payment, it actually goes on the principal, but your next payment is still due. It doesn't affect your next payment. Does that make sense? Cutting away on your balance. So what you're doing is you're taking payments off the end of the loan. Yeah. Most home mortgages are simple interest. Again, for that reason of you're expected to make a payment every month. So let's look at how we calculate the amount of interest in simple interest. The interest amount we represent with the letter I. Is equal to P times R times T. So like we said, the I is the dollar amount of interest that we are earning or paying. P represents principal. That is the starting amount or the beginning balance at the beginning of the loan or the investment or the beginning of a period. R stands for rate. The rate, as we talked about 6 weeks ago, is your percent as a decimal. And time, T stands for time, and the time is always in years. So that calculates the amount of interest. Every loan starts with a principal, often called PV or present value. Present value is what it is worth in the present or what it's worth right now. And that can be thought of as a timeline similar to what we did with our invoices. That timeline advances into the future to take us to something called FV or future value. Which is your maturity. And of course, what happens in between there is your interest. So even just by looking at this timeline, you can see the maturity value or future value is equal to your principal plus the amount of interest that has been earned on it, which makes sense. MV is maturity value. Now, in many cases, a problem's not going to actually come right out and ask, what is the maturity value? I mean, we'll do that a couple of times at the beginning just for clarity. But often it'll ask, how much what will the balance be, or how much do you have to pay back? That's implying maturity value. interest plus the original amount. So let's take a look. Let's say if you borrow $4,000 at 7% simple interest for 4 years, how much will you pay back? And no, you cannot say nothing because I'm going to skip the country and change my name. I had a student try to claim that one. So anyway, we're going to start out by finding the amount of interest. Remember our formula, I equals P times R times T. What is P here? P. The principal is the amount we start with. That's the $4,000. In this case, we borrowed it, so that's the amount we borrowed. So then 7% as a rate is 0.07. T, 4 years, 4. So we just multiply that out. 4,000 times 0.07 times 4 gives us $1,120. That's our interest. So that's the dollar amount of interest. Did we ask for the amount of interest? No, we asked how much will you pay back? That's the maturity value. Yeah, it's your principal of 4,000 plus the 1120. $5,120 is what you'll pay back. Not so bad? No, I heard you say, nope, that's it. That's it. Now, if you were looking at monthly payments, that's a little bit more difficult to figure out. There's an amortization that occurs for that because the balance goes down. Now, they used to do that on a lot of loans. They would figure out the whole interest amount at the beginning, and they would just total it up. That way, there was no incentive. If you made a payment early, you still paid the same total. That kind of like what you were saying is if you made the payment early, you were still going to pay the same total amount. That has been banned in most states. Yes. Well, the Federal Reserve put a lot of restrictions on it, and each state put additional restrictions on it. As far as loaning, it is banned nationwide. If it, and I should say, if it is loaned through a bank. There are different financial institutions that are not part of the banking system that have different regulations. And those are usually regulated state by state. A lot of people don't realize some of your investment is actually considered part of the insurance industry. Yeah. So now on that one, we went for 4 years. Not very often will a bank let you go 4 years without building any interest or doing anything like that. They don't like to do simple interest for 4 years unless something's going to happen in between there. So typically they would do compound interest on that length of time. So simple interest usually takes place on shorter term investments or loans. So let's say that Pam invests $9,000 at 6.4% simple interest. Side note, I'm going to stop saying that simple interest because from now on, unless it says otherwise, we're going to assume it's simple interest. For 3 months. What is Pam's final balance? Okay, so again, the amount of interest equals PRT. What is the principal here? Yes, the 9,000. What is the rate? 6.4%. So as a decimal, that'll be 0.064. Now our time is 3 months. We said our time was always in years. How do we express 3 months as years? 0.25 would do it. We'll just 312, 3 over 12, right? 12 months in a year, we're going to put it as 3 out of those 12 months. We're going to make the assumption when they use the term the months, we're going to assume that all 12 months are the same size. So it doesn't matter which of the months we're using. So 9,000 times 0.064 times 3 divided by 12. Notice I didn't have to enter that as a fraction, by the way, 3/12. I just enter times 3 divided by 12. I get $144. That's the amount of interest. Am I looking for the interest? No, I'm looking for the final balance, which is the maturity value. 9,000 plus the 144, and you are correct. That gives you $9,144. Any questions so far? So Alex borrows $3,500 at 7.1%. Again, I'm not going to write it, but it's assumed simple interest for 8 months. How much does Alex pay in interest? Tell me what to do. So our principal is 3,500. Our rate is 0.071. And yes, 8 months is 8 over 12. So 3,500 times 0.071 times 8 divided by 12. 165.67. $165.67. Now, do we need to add that on to the 3,500? No. Just says how much interest is paid. So that's the answer. That's the interest. Any questions? One for you guys to try in your notes. Taylor invests $4,800 at 5.75% simple interest for 6 months. Find Taylor's final balance. I'll give you guys a couple minutes. So the amount of interest is found by doing what? 4,800 0.0575, 6/12. $138 is correct. $138. Are we done? We do have to add that on. We are finding the maturity value here. So 4,800 plus 138 is 4,938. Any questions? Sam invests $4,000 for 3 months and earns $74 in interest. Find the rate. So this is still interest equals principal times rate times time. The difference is this time we know the interest is $74. The principal is 4,000. We're missing the rate this time. R. 3 months is 3/12. Now your textbook gives you different formulas for each different type of problem depending on what number is missing. If R is missing, it tells you R is equal to I over P times T. Well, we don't need to memorize different formulas. This formula handles it all. We just have to do a little algebra and solve the equation. So the 74 on the left side isn't going to change. But we are going to multiply 4,000 times 3/12, which gives us 1,000. So 74 equals 1,000 R. Then what? Divide by 1,000, which gives us 0.074 equals R. What's that tell us? Yes. Move the decimal 2 spots. It is 7.4% is the interest rate. Now in this one, I had planned it so that those two numbers, the principal and the time combined to make a nice even number of 1,000. Many times they won't. And when they don't, we have to be careful. If we're going to write them down and type them back in the calculator, we are risking having some round off error. So let me give you an example of that. Sam invests $6,000 for 8 months and earns $112. Find the rate. So I equals PRT. What goes in for I? 112. What goes in for P? 6,000. What goes in for R? R, right? That's what we're looking for. What goes in for T? 8/12, 8 months. This one's still going to come out nice, isn't it? One of those days. We're going to combine the 6,000 times 8/12, which gives us 4,000 times R. When you divide that out, if you do it on your calculator, like I said, in this case, it comes out to be an even 4,000. But let's just pretend that's a really ugly decimal that keeps going. We can leave that in our calculator. Don't hit clear, whatever you do. When our next step, we're going to divide by 4,000. So we're left with R on the right side. On the left side, we have the 112 divided by that 4,000. So here's what you're going to do on your calculator. You're going to type in the 112. You're going to hit divide, and instead of typing in the number, you're going to hit second and then A on S. What that's telling your calculator to do is divide by the previous answer. So that way, if that is an ugly decimal, it's going to use the exact number rather than any rounded number you may have written down. So we get 0.028, which is what as a percent? 2.8% is what we're going to earn on that one. If Stacy's interest for the month is, oh, let's put down here $32. Find the balance, the beginning balance on a loan if the rate is 6.4%. I equals PRT. What's going to go in for I? 32 bucks. What's going to go in for P? Trick question. It's P. That's what we're looking for. The beginning balance is the principal. What goes in for R? 0.064. T is a little bit trickier here. It says for the month. So it's 1 month, 1/12. Now we are going to need to do some combining here again. The 32 doesn't change. Over here, however, we're going to take the 0.064 times 1/12. Gives us an ugly decimal, 0.005333. This is another spot where we're going to leave that in the calculator. Do not hit clear. Now to solve this, we're going to divide by that 0.05333. So we're going to do 32 divided by, and then second answer. Gives us $6,000 is the principal. What do you think? Sure. Kelly pays $48 in interest for a month on a, oh, let's do 7.2% loan. Find the beginning balance. So I equals PRT again. What goes in for I? Careful. $48 is the dollar amount. There we go. How about P? That's what we're looking for. Good. How about R? 0.072. Yep. And T? 112. So the 48 doesn't change. 0.072 times 112 is 0.006. Then what? Divide by the 0.006. You got it. Was that 8,000? Equals P? Perfect. Find the rate if a $9,000 loan earns $135 in interest over 3 months. Try that one in your notes. I'll give you a few minutes. So if I equals PRT, what goes in for I? 135. What goes in for P? 9,000. What goes in for R? R. What goes in for T? 3/12. Very good. Now we combine. 9,000 times 3/12 is what? 2,250 times R. And then divide by the 2,250. R is 0.06, which is 6% interest. How many of you had that? How many of you would have been there in a couple minutes? Any questions on that problem? $6. Did you have 2,250? 9,000 times 3/12? Wrong number? Okay. That does her. Another one for you to try. Find the principal if an investment earns $63 at, oh, let's see here, 5.4% for a month. I'll give you a minute to try that. I equals PRT. What goes in for I? 63. P? That's what we're looking for. R? 0.54. And T? 1/12. And then we do the 0.054 times 1/12 gives us 0.0045. And then okay, so does it look like this? Something like that? with that little E and a -3 or something at the end, your calculator is stuck in scientific mode. On break, I'll show you how to change it. Now we're going to divide this out, divide by 0.045, 0.0045, I should say, which is going to give us, what, 14,000? Yep. Yep. If you keep it in your calculator and just hit, divided by second answer, it's still the correct number, it's just in scientific notation. Stat 2 is a mode where it's a type of statistical calculation. It could, depending on the calculator, it's a summary statistics 2. There should be an REM key somewhere, or MEM, I should say. Yep. Hit MEM and then reset. So anyway, I'll look at that on break for you too. So anyway, is there a stat key somewhere, STAT? We'll look at it on break. How long does it take for $5,000 to grow to $7,000 at 8% interest? So again, I equals PRT. What is I here? And it's not as simple as it looks. I is going to be 2,000. Where do I get 2,000 from? I had to subtract. We grow from 5,000 to 7,000. The difference is $2,000. That's the amount of interest. Principal is the 5,000 that we started with. What's R? 0.08. And T is what we are looking for. 5,000 times 0.08 is 400, correct? Now we divide by 400, and we get 5 equals T. What does that stand for? 5 years. T is always years. How long will it take for $3,000 to double at 6%? What goes in for I? $3,000. What goes in for P? 3,000. Now, let's clarify some things here. The starting balance is 3,000. If it doubles, it would be at $6,000. We subtract that, that means it had to grow 3,000. R is 0.06. T. Then what? 3,000 times 0.06 is 180, I believe. And then divide by 180. 3,000 divided by 180 is what, 16.66666? That is 0.67 years. How long does it take for $4,300 to double at 4%? Try that one in your notes. So our interest is 4,300. Our principal is 4,300. Our rate is 0.04. We're looking for the time. 4,300 times 0.04 is 172, correct? Indubitably. Divide by 172, you get 25 years. Any questions? Because it's not coming out to a small number, so it doesn't give him the scientific notation. It only gives you a scientific notation if it comes out to a number less than like 0.01. It's a minute early, but let's go ahead and take our break. We'll come back here at about 6:20. So we've done by number of years, we've done by number of months. What happens if we have Kim borrows $2,800 at 9.7% for 90 days. Find the maturity value. Now, the amount of interest is still I equals PRT. What is P here? P is the 2,800, right? What is R? Careful. 0.097. The 9.7% becomes 0.097 as a decimal. Now the big question is, what is T? It's 90 days, but how do we express that? It would make sense to do 90 over 365. Where'd you get the 365? That's how many days are in a year. That is something called exact interest. Exact interest uses 365 days in a year as part of that calculation. However, unless it is otherwise stated, we always assume something called ordinary interest. Ordinary interest assumes same setup, 360 days in a year. Well, why on earth would they do that? Well, holiday is actually a good guess, but it dates back to, just 50, 60 years ago, there weren't calculators. So banks had to sit down and calculate all this stuff out by hand. So now if you have a month that is 31 days out of 365, that is a very ugly fraction to use to do your interest calculation, isn't it? So what they did was they just assumed every month was 30 days and a whole year was 360 days. So that made it a lot simpler to do all your calculations. And that it stuck around in the industry even once calculators were invented to do it exactly for another very important reason. Let's calculate the interest both ways here. If I use the exact interest up here, 2,800 times 0.097 times 90 divided by 365, I get an interest. I screwed something up. Let's try that again. 2,800 times 0.097 times 90 over 365. I get $66.97, right? In interest. Down here, I get $67.90 in interest. They get $93 more interest on that loan, don't they? Did you guys get that to come out? Did I say 93? $67.90. But there's 93 cents difference. If I subtract these two, there's 93 cents difference between them. They get 93 cents more interest by using the ordinary interest calculation instead of the exact interest calculation. So even though they've got computers now that do the exact interest real easily, they still use ordinary interest because they get more interest. They can milk a few more cents a year out of you. It's kind of what they're there for, right? You can find exact, they'll specify in the paperwork what the exact interest rate is on it at some point. Yeah, pretty much. Unless stated as exact interest. Always assume ordinary. So if it doesn't say ordinary or exact, you assume ordinary. Now I didn't finish this problem up here. What do we have left to do? Add the maturity value. Now it didn't say exact, so we're going to assume the ordinary. So it'd be 2,800 plus the 67.90. So yes, $2,867.90 is maturity value. Well, yeah, if it doesn't say exact, it's always 360 ordinary. There'll be an exact one or two in there, yes. Of course. Sam borrows $4,200 at 7.9% exact interest for 100 days. Find the interest. Tell me what to do. Perfect. 4,200 is the principal, times the rate is 0.079, times 100 days, and it did say exact interest. So it's over 365. $90.90 interest. Any questions? 90.90. Peyton borrows $5,800 at 7.3% for 110 days. Find the interest. Try that one in your notes. We'll talk. So I equals 5,800 is my principal times 0.073 is my rate times 110 over 360. Perfect. So we get 129.37. By the way, for those of you that are watching what I type in the calculator, you'll notice what I'm typing in is not the numbers that are appearing up here. I'm leaving off zeros here, 2 zeros here, and moving the decimal point back. Okay. I just wanted to make sure nobody was looking at what I'm punching in the calculator and wondering why is he using different numbers? I had done it once or twice before. So Stacy borrows $13,700 at 8.2% for 210 days. Find the interest. I'll give you a minute. So I equals 13,700 times 0.082 times 210 over 360. That didn't work. $655.32. How much would Stacy save using exact interest? I'll give you a minute to figure. So using exact interest would be 13,700 times 0.082. The only thing that changes is it's 210 over 365. It is, I'm getting 646.34. So the difference would be $8.98 if we subtract those two numbers. So you notice to the customer, it's not a huge deal. I mean, 210 days is 7 months. It's $9. It's just over $1 a month, $1.285714 a month. But to the bank, if they have several customers that are paying that extra buck a month, that's a big deal to them. I was gonna say that's usually 2 days worth of lunch for me. But anyway, Pete borrows $4,400 on May 17th at 5.75% interest. How much is paid back on August 29th? Okay, now you recall back when we were doing invoicing, there was a magical little page in our book that we used that had a calendar with all the days of the year. Page 396. That page is going to become useful again right now. So if you look up in that table, what day of the year is May 17th? $137. What day of the year is August 29th? $241. So this is 241 minus 137, or 104 days. So now we'll find our interest using the $4,400 times what are we going to use here? Yep. Well, it's just 3/4 is 0.75. Yeah. But you could do the 5 times 4 plus 3 is 23/4, then divide it. Give you the 5.75. That works. That's fine. It still works. So then we've got the 104 days over what? 360, because it does not specify. Giving us $73.09 in interest? Yes or no? Now it asks how much was repaid. Perfect. So we add that back to our original 4,400. What's repaid is $4,473.09. On November 13th, Pat borrows $8,500 at 6.8% exact interest. How much is paid back on February 27th? I'm going to give you a minute to try this one. What day of the year is November 13th? 3/17. February 27th? 58. Now, to do this, we've got to take 365 minus 317. That's going from a November 13th to the end of the year. That gives us 48 days, right? To that, we have to add the 58 days into the next year, which gives us 106 days. Anybody want me to give them more time to calculate it now that we have the days? Okay, we'll give you another minute or so. Okay, so I equals 8,500 times 0.068 from our 6.8% times 106 over 365 because it did say exact interest. How many did you put 360? Bless you. Nobody got caught with the 360. Good. 167.86 is the interest. We're going to add that to the 8,500. $8,667.86. How are we doing on these so far? In that case, I've got some money I would like to loan to you. It is. That's pretty steep there. For $10,000 worth of interest, I will gladly loan you $8,500 for the next 100 days. Time to sell a kidney right there. Okay, we're going to talk about something called partial payments. Now, in the last unit, we had partial payments where it was we paid off part of an invoice, and we had to worry about discounts on those partial payments. What's going to happen here is, let's say Steve borrows $8,000 at 6.5% for 90 days. Find the balance due. The balance due is the amount due at the end of the 90 days. Well, we've already done similar things to this. 8,000 times 0.065 times 90 over 360, which is going to give us what? $130 in interest? So 8,000 plus 130, $8,130 is the balance due. Instead, though, what if Steve pays $4,000 at day 40? So what changes here? Well, on day 40, we have that payment. Now, remember we said when there's simple interest, we only calculate the interest when there's an action or an event on the account. So far, that event has been maturity, the end of the term. Well, here, there's a payment being made. That is an action on that account. So the interest is figured in before any action is taken. So it's $8,000 times 0.065. This is day 40, so it is 40 over 360. You have $57.78 in interest, is that correct? Okay. Now, the way the book does this is it subtracts that out of the payment. And you can do it that way. It comes out the same mathematically. It subtracts that out of the payment, and then what's left of the payment gets applied to the principal. But technically, what is happening is before that payment gets applied to the loan, that interest is being added in. So before the payment is made, the balance is now $8,057.78. That's the balance before the payment. And from that, we're going to subtract the payment of $4,000, giving us $4,057.78. That's the balance after the payment. Does that make sense? So now what's the balance due at the end going to be? We're going to go to day 90. That's the end of it. It's a 90-day loan, right? Well, our interest is going to be figured off of that $4,057.78 times 0.065 still, times, is it going to be 90 over 360? No, because we've already done 40 days. 90 minus 40, there's 50 days left. So that is 50 over 360. So 4057.78 times 0.065 times 50 over 360. 3663. So the balance due at the end is the 4,057.78 plus $36.63. That 4 disappeared on me there. $4,094.41 is what's due. Total interest paid, $36.63 plus $57.78 is $94.41. That one disappeared on me too. Compared to if we let it sit the whole time without any payments, it was $131 or $130 interest. So the balance due would be the $4,094.41. Yeah. The difference in interest or the amount of interest saved. There you go. Would have been the original 130. That's if there's no partial payments, minus the 94 that was charged with the partial payment. That's $35.59 was saved. Yeah. So Sam borrows $7,200 at 9% for 120 days. On day 50, Sam pays $3,000. Fine. 1, the balance due at maturity at day 90 2 total interest paid, and 3 the interest saved by making that partial payment. I'm going to give you guys a few minutes to try this. Okay, so our first action is on day 50. On day 50, there's a payment, but we have to find the interest first. So our principal is 7,200. Our interest is 0.09, and it is day 50. So 50 over 360, because it's not specified as exact. Giving us interest of $90. I'm going to pause there. How many of you had the $90 interest? Okay, so we got a few of you with. Do you see how? Okay, 70s for the second. Yep. So now we got the 7,200 plus the $90 equals $7,290. That is the balance before payment. What's that? So got $7,290. We're going to subtract the payment of $3,000, correct? At day 50, that's what the balance is, yes. Yes. And he's paying $3,000. So the balance goes down to $4,290. That is the balance after the payment. Now there's no other payment, so we go to day 120. That's maturity. We have already used 50 days. So 120 minus 50 is 70 days. Our balance is the 4,290 times 0.09, 70 over 360. Don't know why I put parentheses around that. I never do. So 4,290 times 0.09, 70 over 360. We get $75.08 in interest. So that's going to get added to the 4,290. So it's $4,365.08 is the balance due. So that's the first thing we were asked to find. Where does that come from? The 7, oh, that should be 70. My 0 disappeared on me again. Yep. Thanks for pointing that out. This thing's been acting up today. So the second thing we need to find is the total interest. So it's going to be $90 plus $75.08, so $165.08. Questions so far? Okay, I'll give you a second. Oh yeah. Okay, yeah, something went wrong there. Okay, yeah, we'll do another one. There is a third part then. The amount saved Yes, we have to go back and calculate the total interest. If there were no partial payments, that would have been the 7,200 times 0.09 times 120 over 360, which would have been what, $216? Is that what it comes out to be, is 216? Okay. I'm gonna make somebody double check me on that because mine, 216, okay. My internal calculator has not been horribly reliable today. Perfect. So now we subtract the 165.08 to get a difference of $50.92. That's the savings, yes. So that's what they saved by making that partial payment partway through. You guys want to do another one? Yeah, I figured. So, Stacy borrows $5,100 at 7.5% for 100 days. On day 35, Stacy pays $1,500. On day 75, Stacy pays an additional $2,000. Find the balance due total interest. I'm going to spare you from doing the amount saved. I'm just going to ask for the balance due and the total interest. Let's give you the first step. See if you did okay through that part. Day 35 is the $1,500 payment. So we find the interest here. So 5,100 is the original balance. 7.5%, so 0.075 times 35 over 360. Give us $37.19. That is the interest on the first 35 days. So take 5,100 plus that 37.19 is $5,137.19. That is the balance before the payment. Then what do we do? Subtract the $1,500 payment. $3,637.19. Come on. Is the balance after payment. Doing good so far? Okay. Next event is day 75. What happens there? What's a $2,000 payment? And yes, we do have to find the days. We subtract the 35 days that we already accounted for up here. That's 40 days. What do we do with that 40 days? You got it. Our interest off this balance now, $3,637.19. 0.075 times 40 over 360. I'm gonna double check it. Not that I don't trust you, but well, we get 3031 is correct. So we're gonna add that balance to the 36, 37, 19 is $36.67 and $3,667.50. That is the balance before payment. And we will subtract the $2,000 payment. $1,667.50 is the balance after payment. So then we go to the end of the loan, which is day 100. The next action, right? On day 100, that is maturity, end of the loan. We're going to take that 100, subtract 75, because that's where we're at this last point. There's 25 days gone by. So we take that previous balance of 1667.50 times 0.075, 25 over 360. It is $8.68. So we add that to our previous balance. 1667.50 plus 868. 1676.18 is correct. That is the balance. Well, that is the balance due at the end. So that's our first answer. How much is our interest? We take our interest. We have the 868. We have the 3031. And we have 3719. Here's $76.18 is our total interest. How many got that right? Cool. No, not quite. That was a very profound statement. I would have, but I didn't. I shouldn't find that so funny, but at this point in the night, I do for some reason. On October 27th, Alex borrows $3,800 at 8.25%. On December 3rd, Alex pays $1,000. On January 18th, Alex pays $1,500. How much is due on February 16th? February 16th is the end of the loan. Put it this way, Alex goes to pay it off on February 16th. How much does he have to pay off? Before you get too far into it, what day of the year is October 27th? 300? December 3rd? 337? And February 16th is 47? Okay. So when is the first action? Oops, I got June 18th, of course, is 18. I got put in there. The first action on this account is day 37. How did I get that? Difference between those 2 days. And that is the $1,000 payment. So we find the interest on that day, 3,800 times 0.0825, that's the 8.25%, and it's 37 over 360. $32.22. Perfect. So we got 3,800 plus 32.22 gives the balance of $3,832.22. That's the balance before the payment. Minus the $1,000, $2,832.22 is the balance after. How many of you are at that point? Our next event is that $1,500 payment. What day? Yep, January 18th. So we've got to figure out the days that we're going to take the 337, subtract it from 365. That's 28 days from December 3rd to the end of the year. Plus the 18 is 46 days. So we're going to use 46 days. That's actually day 83. Where did day 83 come from? 46 plus the 37. But the interest is going to be figured out for 46 days. So $2,832.22 0.0825 times 46 days over 360. $29.86. Do you want a second to punch it back in and see what you come up with? 2832.22. Okay. So we add the 2986 to that 2832.22. That's $2,862.08. That's the before. We'll subtract the 1,500 payment. $1,362.08 is the balance after the payment. How many of you are with me so far? So you're a couple bucks off of the first one. But as long as you're staying consistently off by that amount, you know, you did the rest of it right. You just had a mistake right away. So then the end of this is on day, well, we were going to subtract 47 and 18 gives us 29 days, right? That is day 112. That's 83 plus 29 is 112. But it's the 29 days that we're going to use for the interest. So our interest, 1362.08 times 0.0825 times 29 over 360. $9.05 is correct. Yep, we end that 1362.08. 1371.13 is the balance due. The interest, total interest, I didn't ask you for that. No, I didn't ask for total interest on this one. All I asked was the balance due. $71.13. So how much was saved by making partial payments? Well, that's why I was doing the days as I added this up. It's 112 days. So our interest is, what was it, 3,800? $112. Perfect. Get $100.10. So you subtract that, the 71.13 from that, $28.97 difference. That'd be what was saved. Again, I didn't ask for those, anything below this line, I didn't ask for in that problem. So if you got to that line, you got to the 1371.13, you did perfectly. How many of you got to that? Yeah. Good question. For the 100? Let me try it again. Oh, I got 39 instead of 38. That's why. 97.53 is correct. So so $26.40 is the amount saved. Any questions? Not have, no. You just don't need to not have the class staring at you waiting for you to finish. And that's the biggest thing with these problems. It's going to be a matter of, yeah, that helps. Yeah, these are a matter of just slowing yourself down and forcing yourself to pay attention and write stuff down. Taking shortcuts here is not going to help you. But notice I still have everything written down at every step. I've got it recorded. So we're talking about interest-bearing notes. And what we have talked about so far has been something called simple interest notes. Those simple interest notes, on the note is printed a rate, a term, and a face value. That's actually printed on every note. Every note has a beginning value for an interest or a simple interest note. That beginning value is called a principal, as we've been saying. During the term of the loan, there is an amount of interest that is earned. And at the end of the loan, there's a maturity value. And that maturity value is simply the principal plus the interest. That's a simple interest note. When we think of interest, that's typically the way we think of it working. Well, to go with also an interest-bearing note, but it goes with a simple interest note is something called a simple discount note. In a simple discount note, we still have, now here, the face value on that on the simple interest note, the face value is the principal of the note. In the simple discount note, it still has a published rate, a published term, which is the time, and it has a face value. Our timeline looks a little different here, though. There's still interest that's earned. That interest is referred to as a discount. The face value of the note is equal to the maturity value. So let's clarify what that means. Up here in that simple interest note, if you are taking out a $5,000 note, that's a $5,000 face value, that means you get $5,000. And at the end of some length of time, you pay back $5,000 plus interest. Make sense? Down here for a discount note, if you take out a $5,000 note, that means you're going to pay back $5,000. The face value of the note is how much you're going to repay at the end. So obviously that means what you're going to start out with is not going to be $5,000. What you start out with is called the proceeds. I wrote that really horribly. And the proceeds is that maturity value, that face value, minus the discount. So this is a $5,000 note. Yes, you're going to pay back $5,000 at the end, but they're going to take out a discount, and what they're going to give you is less than the $5,000. Does that make sense? Yep, that's fine. So if this is a $5,000 face value note, that means you're going to pay back $5,000 at the end. So at the beginning, you get less than $5,000. Yeah. Let me give you an example. Yes. Let's say that we have a $5,000 note at 8% for 180 days. If that is a simple interest note, which is what we've been working on, the interest is found by doing $5,000 times 0.08 times 180 over 360, which gives us $200 in interest, correct? Does that make sense? So what that means is at the beginning of this term, this is the term here. At the beginning of the term, how much money do we get? 5,000. Simple interest. During the term, there's interest of $200. At the end, we pay back 5,200. If that were, instead of simple interest note, a simple discount note, we wouldn't be calculating the interest, we would be calculating the discount. Guess how we calculate the discount? Exactly the same as we calculate the interest, PRT. Except the principal, the face value, is still 5,000. So what happens here, if we look at our term, the 180 days, there is $2,000 worth of interest as a discount. Where does the 5,000 go here? At the end. 5,000 is what you pay back. So 5,000 minus 200 discount, $4,800 is what you receive. That's your proceeds. Why would they want to do something like this? Well, if you're going to go in to do a title loan on a car, or something like that. Now, let's say your car is worth $3,000 right now, according to their book. Do they want to let that loan go above $3,000? No. So their book says is at the end of 6 months or whatever the term of that loan is, your car is going to be worth $3,000. They're going to figure out what their interest is. That's their discount. Then what they're going to give you is $3,000 minus that discount. They want to make sure that at the end of the loan, your car, if they have to take your car to pay it off, your car is worth enough to do it. Yeah. For other things, a lot of times you'll take out loan with collateral. I know in the business world all the time, if I had when I was running the construction, if I had a job that I knew I was going to have a certain amount coming in by a certain date when I completed that job, I would take out a loan against that. Well, the bank would say, okay, you're going to get, let's say it's $5,000 on this date in 6 months. Well, they're going to take their $200 out right away and they're going to give me $4,800. So they know that when I get my $5,000, I'm not struggling to come up with the extra interest to pay them off. Does that make sense? The good news is we're not going to talk anymore about that discount stuff until next week. It's still part of the same chapter. Yeah. There is a new homework due next Wednesday. No quiz this week. Like I said, those of you at the other sites, I will have your tests sent out tomorrow, so you'll have your tests. Those of you that have them here, again, start your corrections. You guys have a great week.